The Nancy Roman Space Telescope represents one of NASA's most ambitious projects, set to revolutionize our understanding of the universe. Named after Nancy Grace Roman, NASA's first chief astronomer and a pioneer in space observation, this telescope is the next step in space exploration after the Hubble. But what sets the Roman apart isn't just its advanced technology, it's its capacity to cover a field of view 100 times larger than Hubble's, enabling scientists to observe parts of the cosmos that were previously out of reach. As we look to the stars, Roman will be crucial in addressing some of the biggest mysteries in space science today. It will not only allow for the direct observation of exoplanets and planet-forming disks, areas we've previously studied only indirectly, but also help answer pressing questions about dark energy, one of the most perplexing aspects of astrophysics. With Roman, we're standing on the edge of discovery, ready to deepen our understanding of planetary systems within our galaxy and perhaps stumble upon entirely new types of celestial objects. This telescope has been designed to go beyond our current capabilities, opening new windows into the universe's structure and composition. The anticipation surrounding its launch is immense, as we wait to see how it will change the way we perceive space. With its immense field of view and powerful instruments, Roman has the potential to redefine what we know about the cosmos. Stay with us as we explore how this telescope was built, the crucial tests it has undergone, and the groundbreaking discoveries it is poised to make in the near future. Thank you to our channel donors for making this content possible. If you'd like to support our mission, you can donate through the link in the description, and don't forget to subscribe and like this video. The Nancy Roman Space Telescope isn't just another piece of cutting-edge technology, it's a marvel of engineering that combines precision, resilience, and innovation. Every component of this telescope has been meticulously crafted to ensure that it can survive the extreme conditions of space while delivering unprecedented clarity in its observations. One of the most essential parts of the Roman is the outer barrel assembly, a structure designed to protect the telescope and ensure its performance is not compromised once it's launched into orbit. Think of the outer barrel assembly as the skeleton and shield of the telescope. It serves two primary functions: protecting the sensitive instruments inside from harmful light and temperature fluctuations, and providing the structural integrity necessary to keep everything in perfect alignment. This is critical, because even the slightest misalignment in space can result in blurred or distorted images, completely undermining the telescope's mission. The engineers behind Roman took this challenge seriously, creating a protective layer that acts like a house on stilts, sheltering the internal components while maintaining the flexibility needed for adjustments during the launch. What makes this part of the telescope so unique is the choice of materials. The outer barrel assembly is built using a composite material made from carbon fibers mixed with reinforced plastic, bound together with titanium fittings. This combination was chosen because it offers an exceptional balance between rigidity and weight. The assembly needs to be strong enough to resist warping during the intense vibrations of launch, but also lightweight enough to ensure the telescope isn't too heavy for the spacecraft that will carry it into space. Inside the structure, there's a honeycomb design that adds to the strength without adding much weight. This design innovation reduces the amount of material needed while still maintaining a robust framework to support the telescope's other parts. It's an engineering masterpiece, one that showcases how far space technology has come. Beyond its structure, the outer barrel assembly also plays a crucial role in regulating temperature. In space, where temperatures can swing dramatically, thermal regulation is essential. If the materials in the telescope expand or contract too much due to temperature changes, the entire alignment of the mirrors could shift, leading to inaccurate or useless data. That's why the design of the outer barrel assembly incorporates features to stabilize the temperature and keep the instruments operating at their optimal level. This attention to detail in design and materials ensures that once the Nancy Roman Space Telescope is in orbit, it will be able to function with a high degree of precision for the duration of its mission. As we move forward, the focus will shift to the next crucial steps in its preparation, ensuring that every part is ready for the challenges ahead. One of the most critical milestones in preparing the Nancy Roman Space Telescope for its journey into the cosmos was the recent spin test, a rigorous procedure designed to ensure the telescope can withstand the intense gravitational forces it will encounter during launch. This test is a fundamental part of space mission preparation, as it simulates the harsh conditions the telescope will face when it's propelled into orbit. The test took place in one of NASA's most impressive facilities, a massive centrifuge located at the Goddard Space Flight Center in Maryland. So, what exactly is a spin test? Imagine the force you feel when you spin in circles quickly. It's an effect of gravity called G-force. Now, multiply that feeling many times over, and you'll have a sense of what the Nancy Roman telescope experienced during its spin test. In space missions, the equipment is subjected to G-forces far beyond what we feel on Earth, especially during launch. For the Roman, these forces could be as high as 6 to 7 Gs, which is 6 to 7 times the force of Earth's gravity. At these levels, anything that isn't perfectly secured or reinforced could be damaged or thrown out of alignment. To replicate these extreme conditions, NASA placed sections of the Roman's outer barrel assembly, the protective house around the telescope, inside a centrifuge with a 600,000-pound steel arm capable of spinning at incredible speeds. This arm, stretching across a vast test chamber, rotates rapidly to generate the artificial gravity necessary for the test. As the section spun at speeds up to 18.4 rotations per minute, the assembly was exposed to the same type of stresses it will endure during launch. However, testing the entire outer barrel assembly in one piece wasn't possible because it's simply too large to fit inside the centrifuge. Instead, the assembly was broken down into parts, with the house and its stilts tested separately. These components were subjected to intense gravitational forces to ensure their structural integrity and stability. Why is this test so important? Because space launches are incredibly violent. The vibrations and G-forces that occur when a spacecraft leaves Earth's atmosphere can easily cause parts to loosen, bend, or break if they're not designed and tested to withstand these forces. For a precision instrument like the Nancy Roman telescope, even the slightest movement or warping could ruin its ability to capture clear images of distant galaxies and exoplanets. That's why the spin test is such a crucial step. It ensures that the telescope's components will remain secure, aligned, and undamaged as they embark on their journey beyond our planet. With the successful completion of the spin test, NASA engineers now have the confidence that the telescope's structural components can endure the grueling launch process. This milestone brings us one step closer to seeing the Nancy Roman Space Telescope in action. As the preparations continue, the next phase will involve even more rigorous testing, making sure that the telescope is fully ready for its mission to explore the farthest reaches of space. Stay with us as we dive deeper into the final preparations and look ahead to the exciting possibilities that this next-generation telescope will bring to the scientific community. With the spin test successfully behind it, the Nancy Roman Space Telescope is now moving into its next phase of preparation, the final integration and a series of additional critical tests. The next step involves putting the entire telescope together, combining the outer barrel assembly with other vital components like the solar panels and the deployable aperture cover. These parts will be carefully aligned and connected to ensure that everything works seamlessly once the telescope is in space. Once fully assembled, the telescope will undergo thermal vacuum testing. This test simulates the extreme conditions of space, where temperatures fluctuate dramatically, and there's no atmosphere to provide protection. By placing the telescope in a vacuum chamber and exposing it to high and low temperatures, NASA will ensure that the telescope's systems can handle the harsh environment of space without losing their alignment or functionality. Following that, the telescope will face vibration testing, another essential step to verify that it can survive the intense shaking and vibrations of launch. These tests ensure that no component will come loose or shift during the journey into orbit, a crucial factor for maintaining the precision required for space observation. As we look ahead to its expected launch in May 2027, each of these tests brings us closer to seeing the Roman telescope fulfill its mission. Soon, it will be ready to revolutionize our understanding of the universe, uncovering new planetary systems and addressing the mysteries of dark energy. As we prepare for the launch of the Nancy Roman Space Telescope, it's not just the technological achievements that have scientists excited, it's the potential discoveries that lie ahead. Once in orbit, Roman will play a key role in conducting an unprecedented statistical survey of planetary systems across our galaxy, giving us data we've never had before. Its wide-field instrument will allow astronomers to detect thousands of new exoplanets, expanding our understanding of how planets form and evolve. Perhaps even more groundbreaking is Roman's ability to address one of the universe's greatest mysteries, dark energy. By studying the distribution of galaxies and large-scale structures in space, Roman will help scientists explore the nature of this elusive force driving the accelerated expansion of the universe. This is not just a step forward for space science, but a leap toward answering some of the most profound questions about the cosmos. But it's not just the known targets that make the Nancy Roman Space Telescope exciting, it's the unknowns. As Julie McHenry, the project's senior scientist, noted, we could uncover entirely new classes of celestial objects that we currently don't even know to look for. Roman's wide field of view and advanced technology provide a unique opportunity for serendipitous discoveries, leading us to phenomena that could reshape our understanding of the universe's structure. The Roman Space Telescope stands at the frontier of space exploration, embodying the ingenuity and ambition that drive NASA's most significant missions. What Roman uncovers could rewrite textbooks, spark new theories, and inspire generations of scientists to continue probing the depths of space. It's a powerful reminder of the value of space exploration, not only for what we know we will find, but also for what we don't yet imagine. As we await the telescope's launch in 2027, there's a palpable sense of anticipation within the scientific community, and beyond. The data Roman will provide could be the key to unlocking mysteries that have eluded us for centuries, from the formation of planetary systems to the fundamental forces shaping our universe. If you believe in the power of discovery and the boundless potential of space exploration, consider supporting our mission. Every contribution helps push the boundaries of what we know and explore the vast unknown. Subscribe, like, and join us on this journey into the cosmos.